Sixth grade lesson 2.3 is multiplying fractions. And I will tell you, if I had to add or subtract fractions or multiply fractions, my choice is multiply fractions. You'll find this easier than adding and subtracting fractions. There's less steps to it. So I think you'll be happy with this lesson. So I just want to remind you too that multiplication is a shortcut for repeated addition. So if I had 2 times 4/5, really what I have is 4/5 plus itself 2 times over, right? And suddenly I have a common denominator already. I don't have to worry about LCM, common denominators, or anything when it comes to working with multiplication of fractions. There's just some steps I need to take in order to do it, and they're really easy ones. So here we go. Let's go ahead and look at how this works out. And the steps are these. You would just change everything to a fraction, multiply straight across both the numerator and the denominator. We don't have to do common anything. And then convert. If it's improper fraction, we convert it back to a mixed number and simplify. And I'm thinking probably we need to just dust off a few cobwebs about first how to change everything into a fraction. So real quick, brushing off of cobwebs, if I have the whole number 7, in order to make that a fraction, remember, it's still, if I do 7 divided by 1, that's still 7. I haven't changed the number. So if I have a whole number, I can simply change it to a fraction by putting a 1 under it. If I have a mixed number, let's say I have 2 1/3. In order to make 2 1/3 into a fraction, just a fraction, not a mixed number, I multiply the 2 multiply the 2 times the denominator, basically taking those 2 full pieces of pizza and cutting them into 3 pieces as well. 2 times 3 is 6, and then I add the 1 for the numerator. So multiply, add, and then that becomes your numerator. Your denominator stays the same. So I would do 2 times 3 is 6 plus 1 is 7. Denominator stays the same. These are equal amounts. If your brain needs to see it, let me just show you. There's 2 full and another cut into thirds, one of those pieces. That's 2 1/3. I have a pizza cut into thirds here. I need 7 pieces. Well, there's only 1, 2, 3 of those, so I'm going to do another. 4, 5, 6, so I'm going to do another. 7. Same amount, right? Those are the same. So it's the same way to, same number, same value, just written in a different way. But in order to calculate it, I need it to be in that improper fraction form. And then I will convert it back out at the end if it ends up as an improper fraction answer. So let's look at how we do that. And we may as well use the same number. 7/3, we know it's going to be 2 1/3, right? To convert it back out of improper fraction form and into mixed number form, remember this is just 7 divided by 3. It goes in twice. That gives me 6 with 1 left over. Remainder becomes my numerator. The divisor is my denominator. So that's how I convert it back out again. Hopefully this is all feeling like review, like, yeah, I do remember something like that. And then as we practice it today, it will become refreshed in your mind again. And finally, the review of simplifying a fraction, that's just reducing or simplifying. If I have 4/8, let's say, I want to get it into its lowest form. So I would see what number can divide evenly into both the numerator and the denominator evenly. So I can see that 4 would divide evenly into both. So I'm going to divide by 4 to both. That is 1/2. And if you need to see it in picture form, I have a pizza cut into 8 slices and I get to eat 4 of them. 2, 4, 6, 8 slices. I get to eat 4 of them. This is a pizza that I have cut into 2 slices. I get to eat 1 of them. And you can see the value remains the same. It's just the way it's cut is different. We're simplifying it down because it's not as easy for our brains to see what 4/8 looks like as it is for us to recognize in our brains 1/2. And now that we've dusted off those cobwebs, let's go ahead and go into this lesson. If I had 1/2 and I needed to multiply it by 4/5, the steps would be change everything to a fraction. That's a fraction, so that step is done. multiply straight across both the numerators and the denominators. So I'm going to do 1 times 4 is 4, and 2 times 5 is 10. And I convert it if it's an improper fraction. That's proper. It has the small number above the big number. Improper is when it's like upside down, sort of like a snowman. Small number above the big number is proper. We don't want your snowman upside down where the small number is below. You do need it that improper for when you calculate, but when you finish calculations, you want to convert it back, put him back on his bottom and not on his head. So that's what I mean by convert. So this is proper, small, big. So 4/10, but it can be simplified, it can be reduced because they're both even numbers. So 2 divides evenly into both of those. So I'll divide 2 into both of those to simplify. 4 divided by 2 is 2, 10 divided by 2 is 5. That's as simple as it gets, and ta-da, we're done. Let's look at another one. Let's look at one that throws those mixed numbers at us. So change all to fractions is my first step. So that's going to be 1 times 4 is 4 plus 1 is 5, 5/4. 1 times 3 is 3 plus 2 is 5/3. Now they're both in fraction form, improper fractions. I knew they would be because it's more than one, or it's one or more. Now I'm going to multiply straight across numerator and denominator. 5 times 5 is 25. 4 times 3 is 12. And I have now an improper fraction, the larger number above the smaller number. So I just go ahead and convert it by dividing and making the remainder the numerator. So 25 divided by 12. Well, 12 times 2 is 24. It leaves me with 1 out of 12. 12 coming from right here, left over. If I can reduce that fraction further, I would, but 1/12 is as reduced as it gets. That is the answer. All right, and let's not let them scare us off with doing this with order of operations, because we can still do this. Remember, it's like having a whole waffle. You're not going to shove it all in your mouth and do it all at one time. You're going to take bites, and that's all order of operations does for us. So reminder of our order of operations, anything in parentheses happens first. Any operation in parentheses happens first. Then clear all your exponents, clear multiplication or division, whichever comes first from left to right, and clear add subtraction, whichever comes first from left to right. So I have 4/5 plus 6 times 3/8. So in the parentheses, I have an operation here, so I need to clear that. So that's what I will do first. And this is a multiplication with a fraction, so I change everything to a fraction. So 6 will be 6/1 times 3/8. Multiply straight across. 6 times 3 is 18. 1 times 8 is 8. I'm going to leave it like that for right now because I'm going to go into adding that later. So cross off what I did, bring down what I didn't, so that I can do that bite now. So now I'm adding. And on adding, remember, I do need to have a common denominator. So I think what I'm going to do, because I like to use a lowest common multiple because it makes me deal with lower numbers. It makes it easier to do the calculations afterwards. So before I even go to finding my LCM, that's reducible. And if I can bring that down to a smaller number, that might benefit me a lot. So this is divisible by 2. They're both even, so both divisible by 2. So let me just simplify those real quick here. Divide by 2 to both. This is still going to be 4/5. This is going to be 9/4. Okay. Now, to get my common denominator, I'm looking at the 5 and the 4. Well, I can multiply 5 and 4 together to get 20. I'll put it over here. And what did I do to 5 to get it to become 20? I did it times 4, right? I did 5 times 4. If I do that to my denominator, I need to keep that fraction equivalent. I must do that to his best friend, the numerator. 4 times 4 is 16. And what did I do to 4 to get him to become a 20? I multiplied him by 5. I need to keep him equivalent. by multiplying his best friend, the numerator, by 5. 9 times 5 is 45. Add those together. I'm going to get, unlike multiplication, my numerator doesn't get added together. My denominator doesn't get added together. It just stays that. That's how many pieces it's cut into. 16 plus 45. I don't know that in my head. I'm going to do our little algorithm here that we normally do. 61. Last step, convert it and reduce if needed. It does need to be converted because here I am improper fraction, that upside down snowman. No worries. 61 divided by 20 will go in 3 times, and that gives me 60 with 1 out of 20 left over. And for those of you who printed my notes off before going through this lesson, you would see in my notes that I did this same problem, but I didn't reduce it first. I left it like this, found the common denominator of 40, did all the math. I got 122 over 40, but once I divided it, I got 3 over 2/40ths, and then 2/40ths reduced is 1/20th. So had I not reduced that first, I still would have gotten to the same answer. I just had to I had bigger numbers to deal with, and then I just had to reduce it down till I got to this point. They gave me the same answer, so if you didn't want to reduce it first, you just wanted to go through, you would have been fine. You just had bigger numbers.